This slide shows investor attitude toward the risk. So risk aversion assumed investor dislike risk can require high rate of return to encourage them to hold riskier risk securities. So if there is more risk, investors require higher rate of return, and firm should compensate for the risk, so they encourage them to hold riskier securities. So there is a difference between return on risky asset and risky risk asset. So we can write down as this. In the CAPM, the RS is risk-free rate plus market return minus risk-free rate multiply the beta. And we can rearrange this. RS minus RRF is RM minus RRF multiply beta. So what about this? Yeah, it is about when we hold this risky asset and then risky risk asset, risk-free asset, how much return we get. It is about the risky risk asset over the market and multiply the beta. Beta is kind of risk measure between the market and the specific stocks. In the stocks risk and return relationship, the important thing is these two, the risk premium and the beta. So more important thing is how much our stock move with the market or move opposite direction of the market. So that is the question. So when we construct a portfolio, it means we can buy two or more stocks. The risk measure can be different. Calculating portfolio expected return, the weight is 1/2 multiply high-tech companies expected return, collection agencies expected return. We already calculated at this slide here. High-tech company 12.4 and collection agency 1%. So input the numbers 12.4% multiply 1%. So finally you get 6.7%. This is another method to calculate portfolio expected return. This number is given number at the previous slide. That is same with this, right? Each scenario's expected return. This method can be calculated by two steps. The first three, you can calculate each economic state's portfolio return. So you can get this number from the weight of each scenario, each portfolio, and multiply each scenario's expected return. That is 0%. And I can show you the rest case, the weight of each portfolio and expected return is 40%, 45%, minus 21%. Finally, you get this number, right? And then multiply the probability of each scenario and then multiply portfolio return of each scenario, 0%. And 0.2 multiply 3%, and 0.4 multiply 7.5%, plus 0.2 multiply 9.5%, and finally 0.1 multiply 12%. And finally you get the number that is same with this. So 6.7%. Let me explain this equation one more time. This is kind of IP. This RIP is the portfolio return in each state and subtract by this. This means the mean return of portfolio. And then you calculate each number. Finally, you get the portfolio standard deviation. So finally, we get the standard deviation that is 3.4%. And here is one interesting thing about standard deviation when you construct a portfolio. When you construct a portfolio with high-tech company and collection agency, the standard deviation is 3.4%, and it is much more than either stock standard deviation. High-tech company, that is 20%, and when you have only one stock of the collection agency, the standard deviation was 13.2%. And second case, it is more lower than the weighted average of high-tech company and collection agency standard deviation. So therefore, we can conclude that the portfolio provides the average return of component stocks, but lower than the average risk. Why this happen? Because the covariance concept, the covariance of the high-tech company and collection agency. We can say high-tech company and collection agency are not perfectly positively correlated. Yeah, this correlation is related with this covariance concept. As you can see, high-tech company stock expected return goes up when market is good, but as you can see, the collection agency move opposite way, right? And in this case, the market recession, high-tech company lose a lot, but collection agency have some positive expected rate of return, right? So when high-tech company goes up and collection agency stock price goes up, in this case move same direction, we cannot expect this kind of effect. But if these two are not perfectly positively correlated, we can have some benefit when we construct a portfolio. As I mentioned before, when you construct a portfolio, you have some benefit. The benefit is reduce the risk, right? So I would like to show you one mathematical way to prove that. So RP, the portfolio expected return, can be calculated by weight of X, Rx hat, weight of Y, Ry hat. Yeah, we assume invest in two stocks, X and Y, and the variance of this portfolio we can write down as this. And this part is about the covariance of X and Y, right? So rho XY can be calculated by covariance X and Y divided by sigma X and sigma Y. And rho XY move -1 to 1. What does it mean? 1, rho XY equal to 1. What does it mean? If 1 means these two assets, X and Y, move always same direction. Yeah, it also means these two are perfectly positive correlated. Yeah, it means perfectly positive correlated, right? So when you assume the rho xy is equal to 1, this equation can be written as this. Right? But yeah, this is when rho xy equal to 1. So there is no risk reduction. But when you assume rho xy is not same with this, less than 1, we can say this part is smaller than this, right? So it means what? The smaller rho xy means greater reduction for the risk. So like a collection agency case, negative rho xy is very good to reduce the risk. That is conclusion of this part. So you don't have to remember this mathematical equation, but I would like to show you the story how the risk can be reduced. So as we learned before, if these two stocks are not perfectly positive correlated, there is some risk reduction, right? So we can have some benefit when you construct a portfolio. I show the general comments about the risk. For an average stock, the standard deviation is 35%, and most stocks are positive correlated with the market. So the low is between 0 and 1. And combining stocks in portfolio generally lower the risk. So the portfolio risk decrease as stock audit because they would not be perfectly positively correlated with the existing portfolio. So we can write down the perfectly positively correlated as with this mathematical expression rho equal to 1, right? So except this case, we can have some benefit that is about portfolio risk reduced, right? So we can say that is diversification benefit or diversification effect. So this benefit of adding more stocks depreciate, it means disappeared after about 10 stocks. And for large stock portfolios, portfolio standard deviation tend to converge to 20%. There is one interesting thing. When you add more stocks, the portfolio standard deviation converges to 20%, not 0%. Why? There is one risk about the market risk. It cannot be eliminated. This slide shows illustrating diversification effects of stock portfolio. As you can see, x-axis means number of stocks in portfolio, and y is standard deviation of the portfolio. So total risk, it is calculated by diversifiable risk plus market risk as you can see, when you add more stocks, but this part it cannot be reduced, right? So we can say there is two types of risk. The one is market risk. It is about the portion of the securities or portfolio's standard risk that cannot be eliminated through the diversification. And the other one is diversifiable risk. It is about the portion of securities or portfolio standard risk that can be eliminated through the proper diversification. So there are two types of risk when we construct a portfolio. So we can summarize this: the market risk, we also call this diversifiable risk, and we also call systematic risk. In Korean, 체계적 위험. And diversifiable risk, we can say non-market risk, and we can say unsystematic risk. In Korean, 비체계적 위험. When you form a portfolio, this firm-specific risk can be diversified, right? So we can cancel it out. So in the capital asset pricing model, they can only consider this market risk.